Well, hey there, kiddos. Here is your very first video for systems of equations. All we're going to do today is learn what a system looks like, what the solution to a system looks like, and a couple of different ways to find it. So here are your notes. You have this pretty little graph on example 1. You've got two equations. You have graph A right here, and graph B is the solid line. They're graphed on the line for you. And the first question asks, where do they meet? So you just need to find out what this intersection point is. And so if you look, they meet right here at 2, 10. So they meet at 2, 10. This is what we call the point of intersection, or the solution. The word solution means it's where the two graphs meet. At least for a system of equations, the solution is the intersection point. They're the same thing. Now we're going to complete these tables based on what we see in the graph. So graph A is the dotted one. So when x is -2, it looks like y is +2. When x is 1, y is 4. When x is 0, it's 6. When x is 1, we're at 8. And when x is 2, we're at 10. And then graph B, the solid line, same thing. When x is -2, it's way down here. We're going to call that -10. When x is -1, it's at -5. When x is 0, we're at 0. When x is 1, we're at 5. And when x is 2, we're at 10. What you should notice now is that we have these two tables. You can see the intersection point in both tables. It's where they have the same point in the table, so they have an identical point. This is that intersection point. It just shows up in the table. Graph A has it, graph B will have it. So we see the intersection point where there is an identical point. So there's two ways so far to find the solution. You can look at the graph and find out where they intersect, or you can look at the two tables, one for each graph, and then you can see, do they have an identical point in the two tables? And if they do, that will also be the point of intersection. Now 4 and 5 ask us to plug the x value from the point of intersection into the equation for the graph. Well, for graph A, that's y equals 2x plus 6. So we're going to do y equals 2 times 2, because the x value for the point of intersection is 2 plus 6, and then we're going to solve that. That becomes 4 plus 6, so we get that y equals 10, which is what it should equal, because when x was 2, y was 10. We'll do the same thing for graph B. The equation was y equals 5x, so we're going to do y equals 5 times 2, because that's the x value from the point of intersection. If I do that math, I still get that y equals 10, like it should, because from your point of intersection, when x was 2, y was 10. So let's do another one here. They want you to graph these two equations on the same grid. And we know how to graph an equation using slope and y-intercept, so that's how we're going to do this. And then I will show you how to use your calculator to get to the table and write down the values. So we have this 2/3 x plus 2. The y-intercept for that equation is plus 2, so it's going to start here. And the slope is 2 over 3, which means I get to go up 2 and over 3. And plot my points. And then I can also go backwards, down 2 and over 3. And I can connect those and make a line. And that will be our graph A. Then we'll do graph B. Now graph B, 2x minus 3y equals 9, that's not in slope-intercept form. I can't graph it as it is. I'm going to have to take this equation, 2x minus 3y equals 9, and I'm going to have to solve for y. So we have to go back to first semester, remember some things. So I'm going to move the x term by subtracting 2x from both sides. Remember, I like to keep my x term first, so I'm going to write it as -2x plus 9. And then I have to divide everything by this -3. So I can have my equation. So I'm going to get y equals, -2 does not divide by -3 and make a nice pretty number. So we're just going to leave it as a fraction. The negatives cancel, so it's going to stay 2/3 x. And then 9 divided by -3 is -3. So now I have my equation, 2/3 x minus 3. And I'm going to graph it. Well, the y-intercept for this one is -3. The slope is still 2/3, so I'm going to go up 2 and over 3. And then just like before, I will take my line and I will connect them. And hopefully you will notice that these two lines are parallel. Since those two lines are parallel, it means that they are never going to intersect, which is going to tell us something. But we want to fill in this table first. I'll fill in the ones I can from looking at the graph. And so for the first one, when x is 0, y was 2. When x is 1, that's not a pretty number, so we're not going to do that one. When x is 3, y is 4. When x was 5, that's also not a pretty one. And when x was 7, not so sure that's a pretty one either. So we're coming and fill the rest in a minute. So for the bottom one, when x was 0, y was negative 3. When x is 1, that's not a nice number. When x was 3, y was negative 1. When x was 5, and when x was 7, those are ones I'm going to have to look up on my calculator. So here's how we do this on our calculator. In your calculator, you go to y equals, and we're going to type in the equation. Oh, see, I already have one of them in there. I have the 2/3 x minus 3. So we're going to do this bottom one first. To get the fraction, if you don't remember how to do this, you press alpha, the green button, and then y equals. So you'll press alpha and y equals, and it will give you this menu down here in the corner. Option number 1 gives you your fraction. And so that's how you will get to where you can type in the 2/3 as a fraction. If you don't want to do it that way, you can type in 2 divided by 3. Same thing, but this will be nicer for getting our points because it will put all of our y values as fractions and not as decimals. So if I go to second graph and look at the table, here they are. So I can see when x was 1, this is the second one, y was negative 7/3. So in my table here, this was negative 7/3. Then I need 5 and 7. When x is 5, y was 1/3. And when x was 7, y was 5/3. So there are the points in my table, and this is why we used our calculator, because 5/3 is kind of hard to predict on a graph. You have to sort of guess, and that's not very fun. So now let's do the other one, the 2/3 x plus 2. So go back to my calculator and y equals, I have the 2/3 x already. So I'm just going to press my arrow key till I'm over here on the minus 3 part. And I'm going to change that to a plus 2. And I'm just going to type over it. It will change it. Then you do it again. Second graph will give you the table. And so I can see that when x is 1, y was 8/3. When x was 5, y was 16/3. And then when x was 7, I have to go down here, y was 20/3. So those are my numbers. Those were my values. They weren't fun to plot. That's why we didn't use the tables to plot them. We just used our slope and our y-intercept. So hopefully you noticed that these two lines are parallel, which means they will never ever intersect. So I noticed they're parallel. Will they ever intersect? No. What that means is, since they don't intersect, there's not a solution point. They have to intersect to have a solution, so these two lines have no solution. So now let's do the same thing with these two. We're going to have to graph them on the coordinate grid. I'm going to let you pause the video for just a second, do your slope and your y-intercept, graph those on the grid, and then come back and make sure that your lines match mine. Okay, so I got my first graph graphed on here. The 2x plus 2 was easy because I just plotted the points and we had no big deal, and I can probably fill in the table too. When x is 0, y is 2. When x is 1, it's 4. When x is 3, we're at 6. Then we're at 8. Then, oh, sorry, 5 is not at 8. When we're at 5, it's at 12. And when we're at 7, it's at 16. The next one, however, when I solve for y, I end up with y equals 3x minus 3. And if you look at the way our graph is set up, I can't just plot the y-intercept. So that doesn't really help me, okay? But I can go get the table from my calculator, fill it in, and then plot my points. So that's what I'm going to do. I'm going to go over here to y equals. I'm going to clear out this one, and I'm going to type in my equation, which was 3x minus 3. And so I'll go to second graph, and I'll look at my table, and I'll fill it in. So we'll go up here. Obviously, 0 is negative 3 because that's the y-intercept. 1 is at 0, 2 is at 3, 3 is at 6, so we have 0, 3 was at 6, and then 5, this one should be an 8. 5 is at 12, 7 is at 18. So 5 is at 12, 7 is at 18. So I'll plot those points, everything but the 0, -3 on my graph. So 1, 0, then 3, 6, then 5, 12. Oh, look, they overlap there. I'm sure that's going to be my point of intersection. And so then I have my points. I can take my line, I can draw it, and I can plot them. So there are my 2 lines. And hopefully you see that the point of intersection then is now right here, and that's going to be the point 5, 12. Here's also how I know. Here's where the points are identical in each table. Both tables had the point 5, 12. So they meet at 5, 12. So 2 ways to verify the point of intersection. I'm actually going to list 3. Number 1, look at the graph. Where do they intersect? So just find out where they meet. That's the point of intersection. That's the solution. Another way is to look at the table and look at where the tables have identical points. And the third way we did on the very first page is to just plug in the point into the equation and see if it works. And we'll do a lot more of that next week, but for now, that's one way to verify it. So let's look at one more. So now you have 2 graphs, we have to write the equation. Y'all know how to do this. We're going to find the slope, find the y-intercept. So graph A here, the dotted line, it's going to have a negative slope because it's decreasing, so make sure I write my negative, and then I'm going to find 2 pretty points. Here's one, here's one. If I do my rise over run, I went down 2 and over 1, so the slope is -2, and then your x. The y-intercept is right here at -2, so there's that equation. Graph B, I'm going to find 2 pretty points. There's one right here and one up here. And this has a positive slope because it's increasing, and so if I go up, I went up 4 and over 1, so the slope is 4x, but the y-intercept is still -2 because their point of intersection is at the y-intercept at 0, -2. So we're going to substitute that point of intersection into both of our equations and see what happens. So the top equation, y equals -2x minus 2, well, in my point, y is -2, and then x is 0. And I'm just going to do the calculations here. So I'm going to get -2 equals 0 minus 2. Well, 0 minus 2 is -2. And so what happens is this is a true statement. That means that this point is a solution to that equation. If I do the next one, the 4x minus 2, y was -2, x was 0, and the rest of my equation. So then I have -2 equals 0 minus 2 again, which means -2 equals -2, and this is still true. Since plugging in this point into both of these equations gave me a true statement at the end after I checked it, that means that this point is a solution to my equation, and that's how we use that to verify. So you will have homework when you come to class on Tuesday. I hope you enjoy your long weekend, and I will see you then.